Hello and welcome back to Machine Learning. I'm Javita Christie, and in this video, we are going to talk about abstraction and generalization in detail, and we are going to see how a well-posed learning problem looks like. So this diagram you might remember from my previous video where I explained to you how the machine learning process works, and we took great examples about animals and different types of animals and their characteristics. And I had explained that when you have some input data, for example, you've got lots of animals with lots of characteristics, it's impossible to memorize that. And so you would create an abstraction. That abstraction would be that you would classify the animals into vertebrates and invertebrates, which means animals with a spine and animals without a spine, like snakes. So, and then you would also characterize vertebrates into, mammals and reptiles and amphibians. So once you've done that, that is a form of abstraction where you are collecting all these things and then putting them together in a group. And then generalization process helps you to apply that abstraction to real world problems. So if somebody shows you an animal and gives you a couple of characteristics, you could classify that animal as a vertebrate or invertebrate, and then even further classify it as an amphibian or reptile or whatever else is there. So that is the process of machine learning. And we are going to go through these two steps, abstraction and generalization, in a little bit more detail than what we saw in the previous video. So let's begin. So abstraction is during the machine learning process when the data is formed, when the data is given to the machine in the form of an input data. And that data cannot be used in the original shape and form. We all know that whenever the data comes in, it's not always cleaned data with the format that we want it to be in. The abstraction helps in deriving a conceptual map based on the input data. So the idea of abstraction is to get your data in the shape and form that would help you to afterwards perform generalization. So you want a conceptual map of the data using the input data, and that is abstraction. So this map or model, it is known in the machine learning paradigm as summarized knowledge representation of the raw data. So it is a summarized knowledge representation of the raw data. We also studied in the previous video how it's important to create a summary instead of memorizing everything. You cannot memorize names of all the animals and their characteristics. So you have to create a summary and then remember the summary so that helps you to remember everything else. So that's exactly what a machine does too. It creates a conceptual map or a summary of the raw data. So it's a knowledge representation, a summarized knowledge representation of the raw data. And then that helps us to perform generalization. Now, this model that you've created, it can be of one of the following forms. The first could be computational blocks like if-else rules. So if you are creating a model for vertebrates and invertebrates, you would create some if-else rules. For example, if the animal has a spine, then it's a vertebrate. If else, it's an invertebrate. And then within vertebrate also, you can create some if-else statements to classify the animal as amphibian or reptile or mammal, okay? And you could also use mathematical equations to do that. It's not always necessary to create if and else. It depends on your situation. So you could have some mathematical equations. For example, if you were performing, say, linear regression to classify some data, then you would use mathematical equations to find out whether something lies on this side of the line or that side of the line. And then you could use some data structures as well, like trees or graphs. If you were performing something like decision trees or something of that sort, where you want to use graphs or trees to make your decisions, then you could use that. You could also use logical groupings of similar observations. So just like what we did before, we grouped things based on similar observations. you could use that as well to perform abstraction. The choice of the model used to solve a specific learning problem is a human task. Okay, so this is not something that the machine selects for itself. Human beings are always going to be required to do such a thing. The machine is not going to know which model exactly to pick. So we are supposed to pick that model and then create a program for that. And the decision related to the choice of the model is taken based on multiple aspects. And some of those aspects we are going to see here. The first one is the type of problem to be solved. So whether the problem is related to forecast or prediction, analysis of trend, understanding the different segments or groups of objects, etc. So it depends on what kind of a problem it is for you to select a model. So if you had a forecasting or prediction problem, you might want to go with some form of supervised model. Okay, if you have some analysis trend, you might want to just perform maybe regression. Okay, then you wouldn't want to essentially use any difficult mathematical equation. Okay, if you wanted to understand different segments or groups of objects, you might want to use graphs or trees for that matter. So it all depends on the type of problem that you want to solve, based on which you will select a model. The second thing is the nature of the input data, how exhaustive the input data is, whether the data has no values for many fields, the data types, etc. Some models behave well with null values or missing values, and some models do not. So you have to take care of such values. You also have to see how exhaustive the input data is, whether it is enough or it is whether it covers all possibilities or not. So based on that also, the decision about your model can change. And the third one is domain of the problem. So if the problem is in a business critical domain with a high rate of data input and the need for immediate inference, for example, fraud detection problem, which happens in the banking domain. So this is the kind of problem that requires some immediate inference. So you wouldn't want to pick a model that's going to take hours and days to train. So this is another factor that you have to consider while selecting the model. Once the model is chosen, the next task is to fit the model based on the input data. Now, what does that exactly mean, to fit the model based on the input data? Let's understand that with an example. So in a case where the model is represented by some mathematical equation, for example, y is equal to c1 plus c2x, which is, as we all know, a simple linear regression equation. Okay, you'll be studying later. And based on the input data, we have to find out the values of C1 and C2. Okay, that's what we want to find out, the values of C1 and C2 based on the input data. So otherwise, the equation for the model is of no use. Okay, so if you can find C1 and C1, you can use this equation. So fitting the model in this case would mean finding the values of the unknown coefficients or constants of the equation of the model. If you can find C1 and C2, that means you are actually able to fit the model. And the process of fitting the model based on the input data is known as training. So the idea behind this is that you have some input data and you want to summarize it using this one equation. And to do that, you have to find the values of those constants C1 and C2, because if you are able to do that, then given the value of X, which is an independent variable, you will be able to predict the value of Y, which is a dependent variable. This can only happen if you have been able to fit the model on the input data. So imagine having, lakhs of data in your data set, and trying to fit all that or representing all that, summarizing it with just one line. So that's a very difficult process, and that's why it is known as training. So whenever you're trying to fit the model based on the input data, it is called training. Also, the input data based on which the model is being finalized is known as training data. So most of the time, we split our input data into training and test So the data which we are using for training the model to fit the model, that is known as the training data, and that is abstraction. Now let's take a look at what generalization is. So the first part of machine learning is abstraction, where you abstract the knowledge which comes as input data in the form of a model. However, this abstraction process, or more popularly, training the model, is just one part of machine learning. The other key part is to tune up the abstracted knowledge to a form which can be used to take future decisions. So once you have abstracted the model, that's not where the game is over. You have to still consider how that model is going to help you to predict future data or future values of the same kind. And this can be achieved using generalization. So this is quite difficult to achieve. Training the model is quite easy, but achieving generalization is difficult. This is because the model is trained based on a finite set of data, which may possess a limited set of characteristics. So it can happen that the data with which you have trained the model is not enough, and the new data that's coming in on which you want to test your model is data that is much larger or much different than the data that you have trained. But when you want to apply the model to take decision on a set of unknown data, which is usually termed as test data, you will encounter two problems. The first problem is the trained model is aligned with the training data too much. Hence, it may not portray the actual trend. And the second problem is the test data possess certain characteristics apparently unknown to the training data. So once again, just to give you a gist of everything we've seen so far, we have two kinds of data. One is training data, one is testing data. And we also have abstraction, where we try to fit a model, and that model could be anything. It could be an equation, it could be some graph or tree, whatever you want to pick. So you will try to pick that model and try to fit that model on the input data and create a trained model. So now this trained model is then going to be used on some test data to actually make the predictions. Now that is generalization, but there are two problems. The first is the trained model is trained on training data, which makes it easier for it to actually give you the correct answers with the training data. Okay, but it may not portray the actual trend when you try to get in more data, which is newer. And the test data, it could possess some characteristics which are unknown to the training data. So you might not have, if you're performing some classification of positive and negative reviews, you might be, doing that on the basis of some words that you have encountered within the reviews. And suppose some new review comes in with a word that your model has never seen before, then it is not going to be able to analyze such a word. So that is what happens when you have a model that is trained. There are chances that that model is not able to accurately predict the trend. So hence a precise approach of decision making will not work. And an approximate or heuristic approach, much like a gut feeling based decision making in human beings, has to be adopted. So it's not always about being accurate. It's about being quick sometimes, and also if it's an approximate or heuristic approach, it is fine. We don't always want an exact answer. Okay, so that's why it is being compared to the gut feeling based decision making that human beings adopt sometimes. And this approach has the risk of not making a correct decision, quite obviously, because certain assumptions that are made may not be true in reality. So due to the fact that some of the assumptions made by your model may not be correct, you might end up taking an incorrect or wrong decision. And that's okay, because we are trying to get an approximate result. So just like machines, saying mistakes can be made by humans. when a decision is being made based on intuition or gut feeling. And in a situation where exact reason-based decision making is not possible, you cannot really expect the machine to take exact decisions. Okay, so just like human beings could make mistakes in those decisions, the machine also could make a mistake based on the data that it is given. Now let's take a look at what a well-posed learning problem is. So not all the problems should be solved by machine learning. Some problems or most of the problems can be solved by machine learning, and we are going to take a look at what kinds of problems can be solved by machine learning. So for defining a new problem which can be solved using machine learning, a simple framework can be highlighted, and I'm going to show you that now. So this framework helps in deciding whether the problem is a right candidate to be solved using machine learning. And the framework involves answering 3 questions. First, what is the problem? Second, what does the problem need? Sorry, why does the problem need to be solved? And third, how to solve the problem. So there are 3 things. What is the problem? Why do you need to solve it? And how to solve it. So there is what, why, and how. The step 1, what is the problem? A number of information should be collected to know what is the problem. Informal description of the problem. For example, I need a program that will prompt the next word as and when I type a word. So you should use some sort of a description, like you can create an informal description, like you want to create a program that will tell you, that will give you prompts about your next word, just like you get when you're typing on your mobile phone. When you're typing something, it prompts you with the next word. So you want to create that type of a program. And you could use Tom Mitchell's machine learning formalism with ET and P. We studied that in the first video. Okay. Sorry, the second video where we defined machine learning. Okay. So second video, if you haven't watched it about what is machine learning, I have linked it in the description box and you can go through that. So remember that if you are defining a problem, it should adhere to Tom Mitchell's machine learning definition, which says that there has to be some E experience, some tasks to be performed, and a way to measure that performance P. Okay. Let's take an example. Task T. Prompt the next word when I type a word. That is my task. If I type a word, the program should be able to prompt the next word to me or predict what next word I could type. E is experience, so a corpus of commonly used English words and phrases. That would be experience because in order for the machine to be able to tell you what would the next word be, you have to train the machine with lots of English words and phrases. So the machine knows, lots of sentences as well. So the machine knows, if this is the word, then what is the most common thing that can appear after that word? And P is performance. The performance could be the number of correct words prompted, considered as a percentage, which in machine learning paradigm is known as learning accuracy. Okay. So performance is calculating how many correct prompts were there. So sometimes when you're typing a message using WhatsApp or some other application, you might notice that below it gives you right above your keyboard, it gives you suggestions about the next word or suggestions about the current word that you're typing. And you would notice that maybe I'm trying to type machine learning, but the first time that I type machine, it may not suggest learning as the next word. Okay. But when it realizes that I am rejecting all the suggestions given by the program, okay, and I'm writing learning, then the program actually notes that thing down. It notes that after machine, this person is very likely to type learning. And so the next time you try to type, several times you try to type this same thing, eventually you'll get a correct prompt, which is machine learning. So this happens because even that small program on your cell phone is trying to learn. Now, you can have some assumptions, create a list of assumptions about the problem. Okay. Try to find similar problems as well. what other problems you have seen can you think of that are similar that which you are trying to solve. Now let's move on to step 2, which is why does the problem need to be solved? So what is the motivation for solving the problem? What requirement will it fulfill in future? For example, does this problem solve any long-standing business issue, like finding out potentially fraudulent transactions? Or is the purpose more trivial, like trying to suggest some movies for upcoming weekend? Okay, so the purpose of solving the problem is also necessary because some problems would require more accuracy and speed can be compromised. Some problems would um, require more speed instead of accuracy. So that is important. Consider the benefits of solving the problem. What capabilities does it enable? If you are able to solve the problem, how advantageous is it? It is important to clearly understand the benefits of solving the problem, and these benefits can be articulated to sell the project later on. Okay, the next question you should ask is how will the solution to the problem be used and the lifetime of the solution that it is expected to have. So that solution may be valid for a couple of months till somebody else finds out another solution to this problem or finds out that that problem is no longer a problem, right? So you have to consider that as well. For how long will your solution be viable? The third step, how would I solve the problem? Okay, so try to explore how to solve the problem manually without the program. And then you detail out the step-by-step data collection, preparation, and program design to solve the problem. Because just like we drew an analogy in the first two videos between machine and human learning, we have to do that every time because the way you think and solve the problem is the way you will program the machine to think and solve the problem. We would collect all these details and then update previous sections of the problem definition, especially the assumption. And that's how you can form a well-posed learning problem. So I hope you understood abstraction and generalization, as well as how to have a well-posed learning problem. I will see you in the next video. Thank you for watching.